Okay, so for this example, Betty makes $2 per hour more than Joe. And in a week where Betty works 35 hours and Joe 30 hours, Betty earns $110 more. So the first relationship we have here is that Betty's earnings for the week are equal to Joe's plus $110 more. Now, Betty's earnings are equal to her time times her wage. Joe's earnings are equal to his time plus his wage. Let's do Joe's first. Joe's time is 30 hours times his wage. We're going to put in W. Betty's earnings are 35 hours times her wage, but we're going to put in W plus 2. Where'd that come from? $2 per hour more than Joe. You got it. So W here stands for Joe's wage. So then 35 times W is 35W. 35 times 2 is 70. Equals, over here we've got 30W plus 110. What would we want to do next? I think you caught it. There's a W on each side, so we have to get rid of the smaller one. So we're going to subtract 30W. So we have 5W plus 70 equals 110. And then now we would subtract out the 70. So 5W equals 40. And then divide by 5. W equals 8. And now we have to go up. W, remember, was Joe's wage. So Joe makes $8 per hour. Betty makes $2 more, so that would be $10 per hour. Any questions? That one is about as complex as I would ever get in this class, maybe a little bit more than what I would give you on a test. Yes, there are going to be more and more word problems as we go on here. Somebody had asked me when the next test is going to be. Test 3 will be July 14th, so 1 week from today. Yes, I'm still waiting on 2 of them to come in. So hopefully they come in today or tomorrow. I plan on coming in tomorrow morning and checking to see if they're in, and then I'll try to get them graded then. But yeah, normally it wouldn't take this long, but I'm waiting on a couple of them to come in. Okay. Next thing we're going to look at, hopefully a little bit simpler for a while for you. We're going to look at decimals. Just like with whole numbers, the key to working with decimals falls in that place value. So we started from our decimal point and we went to the left. We had the ones, the tens, the hundreds, the 1,000s, the 10,000s, the 100,000s, the 1 millions, and so on. Now I wrote them out numerically here because, like everything else in here, we're going to look for a pattern. As we move one place value to the right, the numerical value is always divided by 10. 100,000 divided by 10 would be 10,000. 10,000 divided by 10 would be 1,000. 100 divided by 10 would be 10. 10 divided by 10 would be 1. So as we keep going to the right, to these place values, 1 divided by 10 is 1/10. Dividing by 10 again would be 1/100th. Divided by 10 again is 1,000th, or 1/1000th. And so on. Next would be 10,000ths. I'm always asked, or often asked, why isn't there a ones place on the right side of the decimal point? This is why. As you move to the right, each decimal place, it's divided by 10. So we're continuing that pattern. Now you look at those place values, and you might think they look an awful lot like fractions. And the reason for that is because that is exactly what they are. Decimals are nothing more than a short way of writing fractions that have special denominators that are powers of 10. So if I have 473.26, that literally means 473 and 2600ths. So it really is, a decimal really is a fraction. It's just written in a short way. And if I want to convert a decimal into a fraction, it is just that simple. I write it out the way I would read it. I would read this as 473 and 2600ths. It writes out the same way. Now, once I've converted this to a fraction, or mixed number in this case, I wouldn't leave it like that. Both 26 and 100 can be divided by 2. So I would reduce the fraction to make that 473 and 13/50ths. So let's start out by looking at how do we, I'm going to assume you guys know how to round. I'm not going to harp on that. But as you go through the homework, if you have questions, let me know and I'll go over that more on Monday. But just like with any other rounding, you identify the place value that you're rounding to, and then you look at that next digit to determine whether you stay at that number or you round up. But let's take some time to look at, what if I have 0.675? If I want to write that as a fraction, how would I read that decimal, by the way? 675 what? Tenths, hundredths, thousandths. By the way, a way to double check yourself, there's 1, 2, 3 decimal places. There better be 1, 2, 3 zeros in my denominator. Now, I would not leave this as 675 over 1,000 because both of those can be divided by what? 25 works. 5 would have worked. We'll do 25. 1,000 divided by 25 would be 40. 675 divided by 25 would be 27. 27/40ths is where that one stops. In your notes, I want you to convert that into a fraction and reduce it. So this is going to become 375 over 10,000. Very good. 4 decimal places, so there's got to be 4 zeros. What can both of those be divided by? Okay, you can find 525. If you really looked, you can find they can both be divided by 125. And it eventually comes down to 3/80ths. How many of you had 3/80ths? How many of you would have got there in a few more minutes? Okay. So we can convert our decimals into fractions just that simply. To convert a fraction into a decimal, like 3/4, of course we know that that has to be 0.75. If we didn't know that, the way we would do it is, remember, a fraction is a division problem. It's just 3 divided by 4. For right now, we're going to depend on the calculator to divide that out. hopefully by the end of the day, we'll do some divisions with decimals and we'll show you how to divide it out by hand. Looking at those two, which is larger? Five, two, three, or 5, 3, 1? 5, 3, 1. Yep, this is the larger one. Very good. Bless you. So of these two, which is the larger one? The second one again. Good. You're always, just like with any other number, you are looking at the leading digits and comparing them and moving on if they're the same. But you also have to look at the position. Here, even though 7 is bigger than 1, you have to compare the digits to something in the same place value. The 1 is in the 10th place. You have to compare it to the 10th place here, which is a 0. So just be careful with those. Those weren't too long, but if I had something like this, which one's larger? The one on the left. The first one is, because there's only 4 zeros in front of that one. There's 5 zeros in front of this one. Now, a skill that, depending on what field you're going into, may or may not be important to you, it could be really important to you in some fields, is this. If I give you 0.538 inches, if you're calculating something and you calculate it out that it has to be 0.538 inches, well, any of you that are familiar with a tape measure knows that 0.538 does not appear on a tape measure. So you need to convert that to something that would be a standard fraction for construction or whatever you'd be measuring. So let's say you want to round that to the nearest 16th of an inch. How do we do that? Well, we first make it into a fraction. Now, when we were working with whole numbers, if I had like 7 times 2/3, how did I turn 7 into a fraction? Put it over 1, right? The simplest way to turn anything into a fraction is to just put it over 1. So I'm going to do the same here. Notice the decimal point stays there. It's still 0.538, but I'm going to make it 0.538 over 1. Obviously, that's an ugly fraction. We don't like having decimals within our fraction, and we're going to come up with a way of rectifying that here in just a minute. Right now, this fraction has a denominator of 1. What do we want to have a denominator of? 16. So how do I change that into a 16? I multiply it by 16. 1 times 16 is 16. What does that mean we also have to do here? Multiply the numerator by 16. So it's 0.538 times 16. Oops, I don't want a 2 in there. 0.538 times 16. 8.608. What this is telling me now is that this is between 8/16 and 9/16. 8.6 is between 8 and 9. Which one's it closer to? Yeah, this is a 6. It's 0.6, which means it's closer to the next one up, or 9. So 9/16 of an inch is what I would round that to. What if I have 2.817 inches and I want it to the nearest 32nd of an inch? Well, the first thing is what happens to that 2? Answer, absolutely nothing. That 2 is a whole number. I don't need to do anything with the 2. That's 2 whole inches, whether it's a fraction or a decimal. What I need to change is the 0.817. What am I going to do with it? Put it over 1. And I want it to be over 32. So what am I going to have to do? Times 32. So 0.817 times 32. 26.14. So that is between 26 30 seconds and 27 30 seconds. Which is it closer to? The 26. Now at 26 30 seconds, I can do what with it? I can reduce it by 2, make it 13/16. So this is 2 and 13/16 inches. Now you might be thinking, well, you said to go to the 32nd. Why did I reduce it to 13/16? Because 13/16 is still 26 30 seconds. It's just in a simpler form. So 26 30 seconds would not be wrong. It's just 13/16 is simpler. So I'm going to have you guys try one. .098 inches to the nearest 1/8 of an inch. So what's going to happen to our 5? It's just going to be a 5. What's next? .098 over 1, and then times 8, because we want it to be 8s. So multiply the top times 8 is going to be 0.784, good. Which means that it is between 0/8 and 1/8. Which is it closer to? 1/8. So 5 and 1/8 inches. Any questions? Okay, our next step. I'm going to fly through this part just a little bit because this is stuff that I'm sure you guys are pretty familiar with, and the calculator does this really well. So we're going to move through this kind of quickly. If we have 2.38 plus 15.6, when I go to add those, what do I have to be careful to do? Line up the decimal points. Good. And we went over this before. The reason for that is we can only combine things that have the same name. So lining up the decimal points when we do this guarantees that we are combining ones with ones and tenths with tenths. Now technically I should put a 0 in there, so I have 0 hundredths to combine with my other hundredths. And now I can go ahead and add just like any other number. 8 and 0 make 8. 3 and 6 make 9. The only one difference is before I can move to the 2 and 5, I have to bring my decimal point down. Bringing the decimal point down is just making sure we keep the same name. The tenths stay in the tenths column, the ones are going to stay in the ones column. 2 and 5 make 7, and of course the 1. So in your notes, add those for me quick. Excuse me. Thank you. So we line these up. We have to make sure we put a 0 in this thousands place to kind of fill that place for us. So then we have 7 plus 0 is 7. 8 plus 7 is 15. Now just like any other number we carry, 1 and 9 make 10, so 0, we can carry the 1. Now I'm going to carry the 1, but now I have to come back and drop my decimal point. 1, 5, and 2 make 8, and then the 1. Subtraction is pretty much the same thing. If I have 9.23 minus 6.518. Again, I have to line up my decimal point. And just like with addition, I should, in this case, I actually have to fill in that missing 0. Just like with whole numbers, when I go to subtract, I may have to borrow. 0 minus 8 obviously can't be done. So I'm going to borrow from the 3. It's a 2. What's this become? 10, right? So now we go ahead. 10 minus 8 is 2. 2 minus 1? 1. 2 minus 5. I have to borrow. This is 8, and this will become a 12. The decimal point does not affect my borrowing there. So 12 minus 5 is 7. Just like with addition, I have to bring the decimal point down before I can go past it. And 8 minus 6 is 2. Ones that can get kind of tricky with subtraction might be ones that look like this. Just like any other subtraction with decimals, I have to line up the decimal points. For the 8, where is my decimal point? After it. If there isn't a decimal point in it, it is at the end of the number. So I line up the 2.3574, and I do have to fill in zeros above those extra digits. So I have 4 zeros filled in. So now when I go to subtract, I have 0 minus 4, which of course can't be done. So I go to borrow. Problem is I go here and there's nothing to borrow from. So what do I have to do? I have to keep going. There's nothing to borrow from until I get to the 8. So I borrow from the 8 and it becomes a 7. Well, what that does is makes this a 10. Well, I didn't need it here. I need it way down here. which means I have to keep borrowing. I'm repeating the borrowing process. This is 9, and now this is a 10. Do I borrow again? This is 9, and now this is a 10. And I borrow one more time. That's 9, and this is now a 10. And now I can subtract. 10 minus 4, 6. 9 minus 7, 2. 9 minus 5, 4. 9 minus 3, 6. Bring down the decimal, and 7 minus 2 is 5. Any questions? Multiplying with decimals. 4.2 times 7.34. Just like with fractions, where I do not need a common denominator, or whole numbers, I don't need the same label. Remember, that's because when we multiply, we don't need the same name. The same goes with decimals. I do not have to line up the decimal points. Now, just like with whole numbers, I would usually put the number with the most digits on top. So I'm going to put the 7.34 on top. So the 4.2 goes below it, and I am multiplying. Now, for the next part of the process, the actual multiplying, I ignore the decimal points completely. So I'm going to do 2 times 4 is 8. 2 times 3, 6. 2 times 7, 14, carry the 1. Now, just like any other multiplication, I put in a 0 or I leave a space there. 4 times 4, 16, so 6, carry the 1. 4 times 3, 12, plus 1 is 13, so 3, carry the 1. 4 times 7, 28, plus 1 is 29, so 9, and we carry the 2. And I will add those up. 8 and 0 make 8. 6 and 6 is 12, so 2, carry the 1. 5 and 3 make 8. 1 and 9 is 10, so 0, carry the 1. And 3. So the question is, where does my decimal point go? Okay. Our decimal point will go between the 0 and the 8. The reason for that is you were taught that you count 1, 2, 3 decimal places in the problem. So in your answer, you have to have 1, 2, 3 decimal places after the decimal point. Why is that? Well, we discussed this briefly on the first day. When we multiply, we combine the names. So when that deals with decimals, what that means is this is hundredths, this is tenths. When we combine those, hundredths times tenths is thousandths. Now when we did our whole numbers, I stressed doing estimation before you punch it in the calculator. And I'm going to do the same thing here. It's really easy to punch these numbers in the calculator and miss the decimal point. The decimal point is actually one of the first buttons on the calculator to malfunction. Also, on many of your calculators, it doesn't display the decimal point until you hit the next digit. So when you press the key, it's hard to tell whether it registered or not. But if I'm estimating this, this is about 7, this is about 4. What's 7 times 4? 28. Would it make sense to have this as 3.08? No. Would it make sense for it to be 308? No, it won't. 30 is the only answer that makes sense. That's the only spot that that decimal point can go that makes any sense. If I get 308.28, most likely what happened is this decimal point didn't register. I didn't push it hard enough. Or 3082.8, similar thing. The first decimal point didn't register. when I multiply decimals like this, I can draw a similarity between multiplying whole numbers like this. What was the shortcut for multiplying when there's zeros involved? Well, I do 4 times 2 is 8, and then what do I put after it? 5 zeros. I have 3 and 2 make 5 zeros. When I'm multiplying numbers that are decimals, there's a similar shortcut. 4 times 2 is still 8, but it's not zeros that I'm counting, it is decimal places. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the places after the decimal point work just like the zeros did before the decimal point. The number of decimal places has to be equal to the number of decimal places in the answer, just like the number of zeros has to be equal to the number of zeros in the answer. Okay, let's take a look now at division with decimals. Division with decimals, just like with division in whole numbers that we saw, is an operation that has been drastically changed through the years. If I have 4.28 divided by 0.21. Well, first of all, to divide that out by hand, I'm going to set it up as long division, which is going to look like this. 4.28 divided by 0.21. How do we divide by a decimal? Well, the answer is we try not to. What we would normally do here, what have you been taught to do? Move the decimal point over to make this a 21, right? So what else do you have to do? Oops, go ahead. Move the decimal point the same distance in the number that's being divided. So that's 428. So this is 428 divided by 21. Why are we able to do that? Well, because my 4th grade teacher said so, right? Well, because remember we said that division and fractions can be thought of as one and the same. 4.28 divided by 0.21 can be thought of as a fraction. And I can multiply the top and bottom of a fraction by the same number. If I'm trying to eliminate the decimal point, I'm multiplying by, to get rid of 2 decimal places, I'd multiply by 100. If there was 1 decimal place, I'd multiply by 10. 3 decimal places, I'd multiply by 1,000. You're going the wrong direction. Yep. So the reason I can move both decimal points the same number of places is simply that. I'm considering it a fraction and multiplying by the same number on top and bottom. Now this division, I'm assuming, wouldn't be so bad. 21 goes into 42. Well, 21 does not go into 4, so we leave it blank. 21 into 42 goes twice. So subtract 42, there's 0 left. We bring down the 8. Does 21 go into 8? No, so we put a 0 there. Now normally we would say there's a remainder of 8, but now that we have decimals, we can keep going. We can put in a decimal point and we can add a 0. So now I bring down that 0. Does 21 go into 80? Yes, it does. It goes 3 times. 21 times 3 is 63. There's 17 left over. Now to know where to stop here, we need to know where we want this answer to fall. So let's say I want this to the nearest 1,000. Are we to the nearest 1,000th yet? No. So we can add another 0, bring it down. 21 goes into 170. 8 times. 21 times 8 is 168. Leaves us with 2. Are we done? No. We add another 0, we bring it down. 21 goes into 20. Well, it doesn't, so put a 0 here. That's the thousandths place, isn't it? So are we done? No, we're not. We have to put one more 0 on here. 21 goes into 209 times. That's 189. Why did we have to go one more place? Well, because we're going to the nearest thousandth, but we need one more digit to tell us, does this stay 380 thousandths, or does it have to round up to 381 thousandths? And in this case, the 9 tells us we have to round up. So this is 20.381. Now, just like I said with whole numbers, long division, especially with decimals, is an operation I prefer not to do by hand. So I do totally understand that this is most likely going to be a calculator exercise for you. But some things to keep in mind as you are dividing by decimals. Here I divided by 0.21, which is something smaller than 1, right? If I divide, let's just look at 10. If I divide 10 by 1, what do I get? Not a trick question, that's hard. You get 10, right? Anything divided by 1 is just itself. If I divide 10 by 2, I get 5. If I divide 10 by 5, I get 2. You can see the pattern here is what I'm dividing by gets larger, my answer gets smaller. So what if I do this? What if I do 10 divided by 0.5? Now what I'm dividing by gets smaller, my answer has to get larger. It becomes 20. So when I divide by something that's smaller than 1, I will get an answer that is bigger than the number I started with. So the reason I bring that up is up here, 4.28 divided by 0.21. I better end up with an answer that's larger than the 4. Similar to what we discussed for multiplying by our decimals, we can divide by decimals. Now, if I had 8,000 divided by 20, the shortcut there is do 8 divided by 2 is 4. What do I do with the zeros? I cancel 1 out, and I'm left with 2 zeros, right? Or 3 zeros minus 1 zero, leaving me 2 zeros. When I divide, I subtract the number of zeros. Kind of like when I divide, I subtract the powers of 10 or powers of the variables. Over here, what's 8 divided by 2? It's still 4, but here I have 1, 2, 3, 4 decimal places. Here I have 3. How many decimal places are in my answer? Well, 4 minus 3 is 1. That's just 0.4. Now that we can do operations with decimals, let's look at something like this. So P equals 3.8D minus 1.2M. So just like we did with whole numbers, I'm replacing the letters with their value. 3.8D becomes 3.8 times 2.5. Minus 1.2M becomes 1.2 times 3.1. I use the parentheses for multiplication just because putting in the dot for multiplication can sometimes get confusing with the decimals. So 3.8 times 2.5 is 9.5 minus 1.2 times 3.1 is 3.72. I subtract to get 5.78, right? What do you think? I'm going to stop there because I think you guys have had enough for one day.
Wow.
I know, I didn't push it right up to 11:30 or beyond. Also because this homework, I think, is a little more challenging. You saw that? Yeah. So there is a new quiz due tonight at 11:59 p.m. Oops. Yeah, pretty much. And there's a new homework that is due on Monday. Does it? Okay, I gotta go in and switch that, but just go ahead and keep working past it if it does that. I will change those grades when I transfer them into Blackboard. The homework won't cut you off. It may make you stop and log back into it, but the homework will let you keep working past the due date. So if you run into that, just log out and log back into my math lab and keep working.